Okay, so we're still in our polynomial unit. We're doing day 3 notes. And in day 3, we're talking about Pascal's triangle and how to use Pascal's triangle to expand binomials. Pascal's triangle has ones on the outside. And then you get the inside terms by adding the 2 above it. So 1 and 1, that's a 2. Put ones on the outside. Add these 2, that makes a 3. Add these 2, it makes a 3. All right, who has a question about how to make Pascal's triangle? So I want you to see if you can do the next 3 rows, and then we're going to talk about the notes below here. Okay, so hopefully you're ahead of me. One's on the outside, add these 2. Add these 2. Good. All right, Greg, next row.
5. 10. 10, 5, 1.
Who wants to do the next row?
6, 15, 20, 50.
Anybody else? Okay. Tara, will you read it to me?
1, 15, 20, 15, 6, 1.
Good. All right, so the binomial theorem is not as simple as this definition here. The binomial theorem is actually going to be defined down here, but this whole section is the development of the binomial theorem. So the first thing we're doing is defining a binomial. A plus B is a binomial because it has how many terms? Who said that? How many terms in a binomial, guys? 2, yeah. It's a binomial because it contains 2 terms. And so we're going to talk about what happens when you multiply. So a plus b to the 1 is just a plus b. A plus b squared is when you do a plus b times a plus b and you get this answer here. When I do a plus b to the 3rd, I take this answer and I multiply it by a plus b again and I get this. So this is a lot of work, right? If I asked you to do a plus b to the 4th, you would have to do a plus b times a plus b, then multiply it times a plus b again, and then multiply it times a plus b again. So there's a shortcut we can use for multiplying these. What do you notice changes from one term to the next? So let's see if we're going to answer that one right now. Yeah. So if I'm going from this term here to this term here, to this term here, to this term here, what's happening to my a values? Okay, Courtney says the a values are decreasing. Does that make sense? A to the 4, a to the 3, a to the 2. What's happening to the b values? Increasing. Good. So as we go from one term to the next, we are losing an a and we're gaining a b. All right, if I'm raising this to the 4th power here, how many terms do I have? Terms are here. That's a term, that's a term. How many terms do I have? 5 terms. If I'm raising it to the 3rd power, how many terms do I have? 4. So if I'm raising it to the n power, how many terms do I have? Do I have more terms than the exponent or less? N plus 1, good. Okay, I want you to take a minute and see if you can see a relationship between the coefficients in these binomial expansions and Pascal's triangle. All right, if you're watching a video, I want you to pause the video and see if you see the relationship. All right, so what you guys are noticing is that the coefficients are coming from the rows of the triangle. This row is 1, 1. This row is 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. So if I want to do a plus b to the 5th down here, what are my coefficients going to be? Okay, so you're just noticing it's going to be the next row of the triangle. So I'm going to write those numbers out first. 1, 5, 10, 10. Okay, those are the coefficients. Raise your hand if you have a question on that part. All right, so then the first a is going to be a to what power? It's the fifth, because see, it's the fifth exponent here. That was to the fourth, so that started with a to the fourth. This one's going to start with a to the fifth plus. All right, the next one is going to lose an a and gain a b. So this is going to be a to the 4, b to the what? Just b, good. 10 a, okay. So Greg, go ahead and fill it in your paper. I think you got it. Don't say that. All right, next one, we're going to lose an a and gain a b. So what's the next one? Lose an a, so I'm going to have a to the 2, b to the 3. Lose an a, gain a b. And the last one is just going to be 1 what? 1b to the 5th. All right, so there is a general way to write this, and it actually has a relationship to combinatorics from Algebra 2 class. Remember when you did like 5 choose 2? So that's the notation we're going to use. We're actually not going to get into the combinatorics because we have enough going on in this unit. But I'm going to show you the notation so that you know how to write this in a general form. So the coefficient of the first one is n choose 0. Now that means n is the, let's see, this is the rth element of the nth row. So the 0 element in the nth row. So in the 5th row, this is the 0 element. So that's my first coefficient. A to the n. Oops, can't see. All right, then the next one, we're still in the n row. So when it was to the 5th power in this row, but we're going to choose the next element. So instead of the 0 element, we're going to choose the 1 element. And then we said we lose an a, so instead of a to the n, it's a to the n minus 1, but we gain a b. All right, we're still in the n row, so whatever row this is, and we're going to choose the next element. So this is element 0, element 1, this is element 2. Lose another a, so a to the n minus 2, b squared. Now, you don't know how long your row is because you could be in any row. You could be like in the 100th row. So we're going to do a dot, dot, dot to show I don't know how long this row is. Then you're nearing the n. You're in the nth row, but you're almost at the last term. You're at the n minus 1 term. So when you're at the second to last term, you only have one a, and your b is to the n minus 1. And then finally, you're going to be in the last term of your row, which is the nth term, and you're going to have b to the n. So this is just a general way to write out what we did with our example right here. I know that some of you don't like those general ways with the variables as much as you like the concrete examples, but it's good to be able to do that. Okay, what questions do you have before we move on? The way we're going to figure this out, guys, is by doing examples. So let's go to example 1 on the back. All right, so write down the 6th row. Now, notice, guys, that this is row 0. So row 6 is all the way down here. We're going to just copy that row. 1, 6, 15, 20, 15, 6, 1. Okay, and now what we're going to do is we're going to expand in a very similar way, but we're dealing with the number 2 here. So when I get something like 2 to the 5th, I can actually evaluate 2 to the 5th. So we'll just do one step where we write it out, just like we did for the expansion of a plus b, and then a second step where we evaluate what those 2's are, 2 to the 5th, 2 to the 4th, all of that. So let's start with our coefficients. 1, 6, 15, 20, 15, 6, 1. And the first one is just x to the 6th. The next one is going to be x to the 5th times what? But I don't have a y, so what do I have instead of a y? I have a 2, right. So it's a number this time instead of a variable. So it's going to be x to the 6th. It's 2 to the 1, but that's just 2. Okay, I'm going to lose an x, so this is going to be x to the what? Okay, I had 5th in this one, so the next one is x to the 4, and I gain a 2, so it's going to be 2 to the what? 2 squared, good. Okay, lose an x. 2, yep, x to the 3rd and 2 to the 3rd. Good. All right, so I think you guys know what's going on now. Lose an x, gain a 2. Okay, and now these are going to simplify because we actually know what these values of 2 are. The first one's not that bad, just x to the 6th. What's the next term going to be? Yeah. Yeah, you're right. You guys have to multiply the 6 times the 2. So you have 12x to the 5th. So if you have 6x to the 5th times 2, that makes 12x to the 5th. All right, the next one, 2 squared is 4. So 4 times 15. Some of these you can do in your head. 60, good. Okay, 2 to the 3rd, how much is that? 8, and 8 times 20. 160. Good mental math. All right, if 2 to the 3rd is 8, what's 2 to the 4th? 16, yeah. Okay, so 16 times 15, what's that? You can't do 16 times 15, come on. 16 times 10, what's 16 times 10? 160. 16 times 5 is half of that. So what's 16 times 5? 80. Okay, so I have 16 times 10 is 160. 16 times 5 is 80. Put it together, you have 160 plus 80. 240. Okay. All right. 2 to the 5th is 32. So 32 times 6. 192. And then 2 to the 6th is 64. Okay? So in this expansion, because we had numbers, we had to actually multiply those out. The next expansion is going to be tricky because the b value is a -1. So I'm going to help you get started with that because we're going to do the same numbers, but then I'm going to give you a minute to try to simplify it, okay? So I'm still starting with 1, 6, 15, all right, and then I have 2x to the 6 for the first one. Notice that the 2 is to the 6 and the x is to the 6 together. This is going to be 2x to the 5th and 1 -1.
Wait, can you repeat that?
Yeah. So do you guys see that we started with the same coefficients because it was still to the 6?
So is this the triangle you use for all? Like this is
For any binomial expansion, yes. So anytime you raise a binomial to a power, this is the quickest way to do it. Because the other way to do it is to multiply 2x plus minus 1 6 times, which would be very tedious, probably take a whole sheet of paper up. So even if this seems tricky, it's better than the alternative. All right, so we're going to lose a 2x. So we have 2x to the 4 and negative 1 squared. So now I'm going to pause for a minute because I think you guys see the pattern, and I'm going to let you see how this plays out. When you have 2x in parentheses raised to the 6, the 2 is to the 6th power and the x is to the 6th power. So how much is 2 to the 6 going to be? 64. So this is 64 x to the 6. Okay. You might want to do this in like more than one step now because it's a lot of multiplying to do in your head. This one here, I'm going to multiply these two and I'm going to get negative 6. And then I have 2 to the 5th, which is 32. Okay, we're getting there. I'm doing this with a calculator though. Okay. Negative 1 squared turns to what? Positive 1. So anytime the exponent is even here, it's going to turn to positive 1. So I have 15 times 2 to the 4th. How much is 2 to the 4th? It's 64, 32. This one's 16. Plus, let's see, this is going to be 20 times negative 1, so that's negative 20. 2 to the 3 is how much? 2 to the 3 is 2 times 2 times 2, 8. Okay, 15 times 4x squared. This is going to be negative, so I have negative 6 times 2x, and then this last one is 1. All right, I'm going to pause for a second so you guys can ask questions on that step. I'm still not done. Okay, so the first term is simplified. The next term is going to be minus because of the negative here. And did you guys get negative 192? All right, we said 15 times 16 is how much? We did that already. 240, good. Negative, so this is going to be minus 160. Multiply again. Okay. So this is your expanded polynomial. I'm going to ask you guys to try the next one. Notice that the exponent is 5. That means it's going to be a slightly shorter problem. And you have a different row that you're dealing with. So you want to find row 5 on your triangle and use that one and try to expand 3a plus b. No, because you don't have to memorize Pascal's triangle because you can build it anytime you want it. Do you guys remember about how to build it?
Yes.
Start with 1. And then you have 1, 1. And then you put 1s on the outside and you add these here. So you do need to know how to make Pascal's triangle. You don't need to memorize it. 1 second. All right, for the last example, we're using row 5. 1, 5, 10, 10, 5, 1. Put your coefficients out first. And then your 3a, the first 3a will be to the 5th power. The next one, it loses, so it's going to be 3a to the 4th, and then you're going to gain a b. So each time you go down, you lose a 3a, you gain a b. And then when you expand, remember that this is also 3 to the 5th. 3 to the 5th is 243. All right, you're going to do 3 to the 4th times 5 here. 3 to the 3rd times 10. 3 squared times 10. And so on. And check your final answer. When you finish with this, you're going to eventually be doing the homework problems that are attached.